Okay, this is your second retry, or your second try on this DMR. Tomorrow is your third and final. Treat today like a quiz. See how you do. I do have some answers. If you're not quite ready, I can see some of you are working on that last question. Feel free to keep working. Oh, that last one I put in a bad spot. Let me move it. Please look at those details carefully. Yeah. Let's do a little comparison. If you see the words 12 greater than, that always means plus 12. If you see the words 12 is greater than, then that's where you do this. So if you said, hey, Mr. Anderson, I think you are 40 years old. And I said, nah, 4 greater than that. What would you do? Well, 40 plus 4, right? So I try to think of it in terms of like the words that we normally use just in everyday conversations. Or maybe you'd say 4 more than that. I don't know. Yeah. Where I got the what?
390.
Okay, yeah. Hey, guys, let's look at number 2 real quick. Can anybody explain where on earth I might have gotten that 390 that I have in there in my picture? Mason, where would I get something like that?
It's 130 seconds times 3.
130 seconds times 3. That's exactly right. So, and doesn't that represent the distance of Billy's head start? So if he goes, like Mason said, if he goes 3 feet per second for 130 seconds, you'd find that distance by going 3 times 130. Does that fill in the gap enough? Okay. Thank you, guys. What else can I do? Yes. Yes, ma'am.
Why did you subtract x5 and x8 on the fourth one?
Oh, it should be. It's a 13. When I moved it, I bet you something got lost. Should be a 13. Should definitely be a 13. Oh, I got some hands that.
Yeah, the 7. He's on the 7.
Goodness, sorry. So I moved it, and I think I messed something up here. Okay, so let's do this. You know something's going on when 3 hands go up in unison. You're like, something's going on. Okay, so let's see here. That first, let me just double check this first step. First step looks good. Oh, and the 7 is just a. So what I did here is I canceled these 2 to be a 2 and a 1. So it should be 18 x to the 8 y, and that's it. I think I canceled my 7 and then I left my 7.
Isn't it 5 plus 8? So wouldn't it be x?
13.
I was like, it's 8.
Now
What happened?
Sorry, I'm all over the place right now. There we go.
Okay, good. I got that answer though.
Okay.
He's like,
No, that's definitely the right answer there. 5 plus 8 is 13.
next thing you know, it's going to be like
Okay,
46.
so walking around, I'm seeing some really nice papers. Do you have questions? Number 4? Okay. So I know this is backwards of how some of you guys have experienced math in the past. But with a question like number 4, I am not going to tell you, hey, everybody, step 1, da-da-da. Step 2, do this. Step 3, something else. All I would expect you to do with something like number 4 is to carefully look at what you have and think about what's true and logical and proceed in a true and logical way. So let me give you a for instance. The first thing I see when I see this, to be honest with you, I see the x to the 10 over x to the 5. And my first thought is, hey, if I'm dividing my bases, I need to subtract my exponents. So my first thought, I'll just come over here, would be 14x to the 5th And then my very next thought is, this y to the negative 1, what does a negative exponent mean for us to do?
Flip it.
Flip it. So since it's in the top, it flips down. So my first thought, and notice I didn't say step 1 is always this, step 2 is always that. I just said, man, I noticed that there were some x's being divided, so I went ahead and subtracted the exponents. Oh, I also noticed that there was a y with a negative 1 exponent, so I moved that down. That make sense?
Yeah.
I'm going to try to notice some other stuff. Notice on the other one, I have highlighted in green, I've got a product that's being raised to an exponent. So what that means is that 2, that squared, applies to all 3 factors. So here's my thought. 3 squared? 9. What about x to the 4th squared? What's that? X to the 8th. And then I've got y squared, which is,
2y.
no, it's y squared. Down below, I notice I've got this 7 hanging out down there. I don't know exactly what to do with that yet, but I see x to the 0, and I remember that x to the 0 is 1. I could put times 1 right there, or I could just leave it as a 7. Either way works. So again, please understand, at no point did I say you have to do this, you have to do that. I just noticed stuff, right? So pay close attention and say, whoa, I'm multiplying these together, I'm dividing these. I've got a base to a power with a power. Notice what you have and just be logical about what you do. Let's keep going. I didn't exactly do it this way the first time. You could do it this way if you wanted to. You could say, I'm going to multiply the numerators together. That's logical. It's okay to do it this way. 14 times 9 is 126, I think. So it'd be 126. Then it would be x to the 13, y to the 2, all over 7 times y. Again, all I would call on you to do here is say, wait a minute, that's not logical. Or, oh, that is logical, right? Trying to follow the established ideas that we've learned about math. Then my last couple of things here would be to recognize that this 126 and this 7 reduce. They reduce down to be, it must be 18, right? So it would be 18 over 1. So it would be 18 in the top. I've got x to the 13. And then lastly, notice that I've got y to the 2 over y to the 1. What do I do when I divide my bases? Subtract my exponents. So it would be y to the 2 minus 1, which is just y to the first. And I arrive back at that same answer. So folks that were vocal about that one, is that helpful?
Yeah.
Be flexible in your thinking. Don't feel like you have to do step 1, step 2, step 3. Just be logical about what you do. Anybody else with a question? Number 3 go okay? You getting good at radicals? I hope you are. Mason, what don't you understand?
That's fine. It's a different thing.
Oh, a different thing? Okay. So let's see here. I'll remind you of this again today, like I did yesterday. Let's say it's Thursday afternoon, here in a couple hours, it's 4 o'clock, and you think, what do I have on tap for tomorrow? Oh, yeah, it's a DMR quiz over this stuff. I'm feeling really shaky about that number 4. Those exponent things are just bugging me still. You should do nothing about it, right?
Yep.
Wrong. Well, I guess if you don't care about getting poor grades and not understanding anything, you should do nothing about it. But if you care, if you really value your education, you will probably say something like, maybe I should study, maybe I should practice a little bit. You've got your packet, you've got the video that's being made right now. You could use it to practice. Guys, honestly, if you really care, you'll probably do something like that if you need to. If you don't, you won't, and you'll get a 1 out of 4 or something, right? That's just how life goes. But I hope you'll make the right choice. I hope that you will decide to do some practicing and studying. Should be in good shape. Any other questions? Okay, fair enough. The next thing I want to do for you guys is I want to hand back your quizzes from yesterday. So I've already handed out your retry assignments. So these will go along with that. Let's see, you're on different places now that I moved you. There you go. Okay, Sophia here is one for you. So messed up that you guys didn't
I got that right. I got my name. I got my name What else do you think?
That would be, this one would be 4, level 4.
Oh, I thought it was 7.
Just take 4 out and put everything else like over parentheses. And then if that's not that, then that's number 3. And then a 1.
No, it's negative 8 times negative 1.
That's the negative 1.
Okay, listen up, please.
And then you add them, that's negative 9.
Hey, guys,
Negative
what up, please?
9.
So, I know it's a battle. I know it's a battle all year to change your mindset. I know that for most of you in middle school, and maybe a lot of your other classes here at Valor, like every assessment is a final summative assessment. Whereas in our class, these are called formative assessments. In that, if you did great on a quiz like this, you say, awesome, I know how to factor. If you did terrible on a quiz like this, you say, gee, I don't know how to factor. Maybe I should do something about that and retry it. Does that make sense? So there's no real judgment yet, right? This is not a summative assessment, purely formative. So I hand this paper back to you and you have a 3 on there. You say, I think I'm doing okay. You get a 0 or 1 on there, you're like, I'm not doing good. Now listen, guys, hey, listen. Your response in middle school was probably like, oh man, I did terrible. I guess that's just a bad grade in the grade book. Your response now should be very different. Your response now should be, oh, I didn't do very good, I did terrible. I better do something about it, like get help, practice, study, retry. Get it? Make sense? So I hope that you'll do that. The good news is what we're about to do here today is only going to serve to help, because all of our work today is going to involve factoring. And so it could be that today is the day where the light bulb comes on a bit brighter than it was last week when it comes to factoring. Maybe not. Maybe it'll be tomorrow. I don't know. But that'd be the hope. That make sense? One thing I would offer to you tomorrow, are you listening? One thing I would offer to you tomorrow during lunch, if you got your quiz back, and I don't know, maybe you're in the situation where you think, I thought I did terrible when I left. I knew I did terrible, and I got it back, and I definitely did terrible. Maybe you're in the boat of, man, I thought I knew that stuff. I thought I was going to get a 3 or a 4, and I definitely did not. Wherever you find yourself, tomorrow during lunch, I'd love to offer you some help. This is a wide open opportunity. 1 of you might show up, 0 of you might show up, or 16 of you. There's going to be at least 1. 16 of you might show up. I don't know. We'll see. It'll come down to you might be already have an appointment scheduled during lunch, but if you don't, it's going to come down to how much do I care? I hope that you care enough. I can't make you care. I really can't. But I hope that you do care enough to show up and improve if you need to improve. That make sense? So let's do a little practicing here. I want you guys to go backwards in your packet a little bit. There were a couple of examples that I would like to cover from yesterday that we didn't. So I think, let's see, I think we did not do number 2, the one you see there at the top. And I think we're just going to try to tie yesterday and today together. So if you would, look at number 2 with me. Does it make sense to you that I'd give you a little direct instruction at the start? I don't want to just set you off on the wrong path. So engage. I'm going to try to get you guys to be able to do this by yourself before you leave today. We'll see. We'll find out how it goes. So number 2. Hey, I've said this before. Say it again. You are crazy if you think you can get this with half your brain tied behind your back due to distraction. You're going to need all your brain. Okay? So please engage fully. So number 2. Is number 2, as it currently stands, factored?
No.
It is definitely not. It's a subtraction problem, isn't it? It's something minus something. Remember, factored means that it's something times something. So we need to try to factor this. When you're factoring, this, guys, this goes right to your quiz right here, the one that I just handed back to you. When you're factoring, you should always think of a certain type of factoring first before anything else. What kind of factoring?
Greatest common factor.
GCF, greatest common factor. So look at those two terms up there, 12x squared minus 4x. Do you guys see anything in common between those two terms? There's definitely a 4 and there's definitely an x. That's right. So here's what I'm going to do. I'll write my greatest common factor out here to the left. And then I got to write what's left over after I undistribute the 4x. That's really what this is. So let's see here. My first term originally was 12x squared. Anybody have a thought as to what that would be after I factor a 4x out? 3x, right? There's a 3 left over because 3 times 4 is 12, and there is an x left over because there used to be 2 of them, but I took one of them out. Now, sometimes people get a little confused by the second term because there used to be a 4x, but I took out a 4x. So if you take the whole term out, there's a 1 left over. So it would be minus 1. Okay. So you know what? Let's investigate. Listen, please. This really goes to the heart of the matter, because factoring is the reverse of the distributive property. Factoring is the reverse of the distributive property, like factoring GCF like this, just reversing the distributive property. So shouldn't I be able to do the distributive property and end up with what I started with? So check this out. What's 4x times 3x? Looking good so far. What's 4x times x? Minus 4x squared, and it doesn't match, right? It needs to be minus 4x, so that must not be correct. So if we did have the 1 in there, check this out. If I have the 1 and I distribute to check, I get 12x squared minus, what's 4x times 1? Just what we were hoping for, 4x. Bray, does that make sense? So please, I would encourage all of you, if you're sitting there like Bray and you think, my mind was telling me it should be this, but now you're telling me it's that? This way, please, Mason. This way, please. Thank you. If there's that disconnect between I thought it was this, really now you're telling me it's this other thing, you need to ask about that. So thank you. Okay, so then once we have this factored, we will use what's called the zero factor property. And the zero factor property is the thing that Mason kind of spelled out for us yesterday. He said if you've got two things being multiplied and the answer is 0, then either one of the two of them or both of them have to be 0. So here's what this looks like. 4x equals 0. 3x minus 1 equals 0. We just said each of those factors equal to 0. So for the first one, how do I get the x by itself? And what's 0 divided by 4? So my first solution is 0. And for the other one, don't I have to add 1 and then divide by 3? So that one, the solution is x equals 1 over 3. Okay. So, ladies and gentlemen, that is exactly what I taught you yesterday. Just trying to connect the two of them together. And I would like to do a little test and see how you're doing. So, if you would, please take a look at number 4. Take a look at number 4. We did number 3 yesterday. And see if you can handle number 4. Okay? There it is on the screen. 16x squared minus 9 equals 0. If you're having a hard time getting started, just need a little help, let me know. What's your neighbor? So Mason, here would be my, so if you're unsure where to start, ask yourself this question first. Is it factored? It is definitely. So we'll go there. So it's not factored, so we need to factor. We start over the GCF, right? And there's not a GCF.
What is the GCF?
Greatest common factor, like we did in the previous one. Like
In this, what is the GCF?
there's not one. You know, we always want to look for one, and if there is one, we want to factor it out. But if there's not one, there's not one, right? Okay, so once you've determined there is no GCF or you factored it out, you've dealt with it essentially. The next question is this: how many terms are there? 2 or 3? No, there's 2 terms. 16x squared is one term, minus 9 is the second term. Okay, so then the final question you have to ask yourself is, if you have 2 terms, if it's a binomial, ask yourself, is it the difference of squares? It is the difference of squares, so then factor it according to that difference of squares property that we looked at before. That might be the sticky. You know why it's the difference of squares? They're both perfect squares, they're not like terms, right? They're both perfect squares, and difference means subtraction. So I'll show you. It's a whole lot easier for me to show you at this point than to just talk about it. Okay, so guys, isn't it always challenging? Maybe you've never even thought about this, I don't know. Isn't it challenging to think about the way you think? To like ponder the way you think. I'm going to try to help you shape the way you think. So listen carefully. Number 4. Some of you need a lot more direct instruction, do you not? So listen. Okay, so number 1, please recognize that this is not factored yet, right? As it stands, it's not factored. So here's that little flow chart. I'll do this off to the side for you. Your first thought should be, is there a GCF that I can factor out? No. Paying attention, besides 1. You could always factor a 1 out, but we're not going to do that. So did you notice there's not a GCF? Okay. I'm just waiting until it's quiet. Okay. After you've decided that there either is or isn't a GCF, and you've dealt with the GCF, and we have because there's not one, you need to ask yourself another question, and that question is it a trinomial or is it a binomial? Which one is it? It is a binomial. If it was a trinomial, we'd do something a little bit different. We'd do the box thing, right? So it's a binomial. So then the last question you need to ask yourself is this the difference of squares? Yes. And it is, right? The difference of squares basically is 2 perfect squares being subtracted. And isn't that what that is? 16x squared, that's a perfect square. 9, that's a perfect square. And are they being subtracted?
Yes.
Yes. So it's the difference of squares. And this might be where some of you guys might have struggled a little bit. How do I factor this? But I think you'll see it as soon as I write it up here. Check it out. It's 4x plus 3, 4x minus 3. Do you remember this? Like last week, you guys were so good at this. Do you remember? Yeah. We did 2 exit tickets, and I threw some pretty scary stuff at you, and like 18 of the 20 of you nailed it, and the other 2 were like, oh, I get it now. And then we did another one, and all 20 of you absolutely nailed it. Well, it's been like 6 days, and what has happened? You've completely forgot, right? So you're getting another chance to remember. Hey, Mason, Noah, Anya, I want you guys to face the way you're supposed to be facing. No, Mason?
Yeah.
I didn't ask what you're doing. I just asked for you to face this way. And that's all. Okay, so are you guys okay with this factoring? Do you remember the difference of squares? Let me finish this while I have a little momentum. So what I'm going to do here now is I'm going to set each factor equal to 0 using the 0 factor property. And then I'm going to solve. So I would subtract 3 from both sides and divide by 4. Then I would add 3 to both sides, divide by 4. I get x is equal to negative 3/4, and x equals positive 3/4 would also be another solution. Anya, your question.
So, for like, the difference of squares.
Yep.
So, it's the 0 property factor is the same.
Yeah, whatever the factoring was, whether you used a GCF or the difference of squares or the box with the trinomial thing, whatever method you use, once you get it factored, we'll always use the 0 factor property to get us to our finish line.
Okay.
Yep. The factoring method is just whatever it is based on the situation you have. We'll always end up with a zero factor property. Okay, so you've seen it again. You ready to try some more?
Yes, sir.
Flip forward. You need a lot of practice. We all need a lot of practice. So let's check out today. Let's see here. I think, number 1 would be an excellent opportunity for you all to practice. Please try number 1. Remember that flow of thought. Factor the GCF first, and then analyze, is it a binomial or a trinomial, and then proceed from there. Okay? Yeah. That's great. Look at it, just number 1 right there. That's awesome. Yes, ma'am. Okay. No, you're jumping the gun a little bit. Don't erase anything. Back to the GCF. Always look at the leftovers and ask yourself, is it a binomial or a trinomial? Look at the inside. Binomial, is it the difference of squares?
Yes. Hey,
Factor it.
okay.
It's definitely the difference of squares.
Wait, okay.
No, you've got nothing wrong. You've got everything right. You got a little more factoring to do. The same place Anya's at. You backed up the GCF very nicely. Look at the inside and include the leftovers. Is it a binomial or a trinomial? Squares. So factor using the difference of squares. You need to factor this. This is excellent factoring right here. Always look at your leftovers in there and ask yourself, is it a binomial or a trinomial? Then the final question is the difference of squares? Is x squared a perfect square? Is 25 a perfect square? Are they being subtracted? Use that difference of squares factored property. Yes, ma'am.
I got negative x
Each
equals
factor. 3x equals 0.
How do you get 0?
5, not 3. It's negative 5 and 5. Sorry.
Okay, thanks.
No. So in this stage, this should be 3x, right? This, you never fully factored it. When you factor the GCF out, it's perfect. Look at the inside, look at the leftovers here, and ask yourself, you gotta keep going. Is it a binomial or a trinomial? Yep. It's a binomial, absolutely. And the final question is, the difference of squares.
Is that like the one where
Like the one we just did. Yep. Is x squared minus 25.
So what did I miss? I figured it out possibly. Me? I don't.
I'll show you. I'll show you right now.
Um,
Can I show you guys?
yeah.
You guys are you're getting better. I was able to see like 8 or 9 of you guys. You're getting better. Now check this out. Hey, we have time for like 1 or 2 more. You need practice, right? So let's transition well. Here we go. So here was one big piece of encouragement for me as I walked around. Pretty much everybody that I visited with did this. So make sure that you did this yourself. You get that GCF factored out? I think that's what your first step should look like. Are you with me or no? If you're not, let's talk. Okay. Okay. Anytime you factor out a GCF, that's a good move. Good job. But you want to keep going and ask yourself this question. Is the expression on the inside a binomial or a trinomial?
Binomial.
It's a binomial. And then your last question is it the difference of squares?
Yes.
Do you see it? Isn't x squared a perfect square? 25, perfect square. They're subtracted. So here's how that factors. 3x, still there. And then x squared minus 25 would factor as x plus 5 times x minus 5. There's your difference of squares factoring. At this point, you have completely factored it, and you're ready to use the zero factor property, which looks like this. You set all three factors. I know 3 of them seems like a lot. Set all 3 of them equals 0. Thankfully, all 3 of those for you guys are really easy to solve. Wouldn't you get x equals 0, x equals negative 5, and x equals positive 5? You get 3 different solutions, so 3 different numbers work here. They should all check. They should all work. How we doing? Say again?
That's what I got.
Fantastic. Sure?
Yeah.
Okay, let's try number 2. Number 2 is a little different. Come on, let's get at least this example done. Maybe we could even do 2 more. You need a lot of practice. About 6 minutes left. We might be able to get 2 of them done. Let's at least get this. Good news is we will keep practicing this tomorrow. Hopefully you're getting better. Try to get things even better by tomorrow. Oh. Yes, are you doing something?
No, it's not.
Well, before you do that, it's a trinomial. So if it's a trinomial, we don't even bother with the difference of squares thing. The trinomial, we're going to go straight to 5.
Oh, wait.
18 divided by 2.
You don't get it?
44 times
2 suggestions for you. In about 2 minutes, really pay close attention. And, hold on, I'm still talking to Elliot. And if it's still not there yet, there's videos from all last week where we do the box method over and over and over.
8 times?
So I'll do my best to explain it to you here in a second, but get your box started. Yes, ma'am.
So for the box,
This should be x squared.
oh, yeah. So for the box method, is it like this is A and this is C? Oh, it's not these ones, right? It's the factors.
It's the ones that you're currently working with.
Okay.
Yep. Mason, you want to get the GCF out first? So far, so good. You got the GCF out first. Yeah. So listen now. Once you get the Once you get the GCF out, ask yourself: is the leftover on the inside there? Is it binomial, trinomial? It's a trinomial. So how do we factor trinomial? 1, 2, 3, 4. Oh, you use the boxes. There it is. That's you do the boxes with the ABC. Yes, ma'am.
So when I do this, do I use, so when like after I do all of this stuff?
You use the you use the one that you're currently working with. Yep.
C equals 22. And then we do like
Okay. We have about the right amount of time left for us to see this here. Hey, listen. I'm getting more encouraged here because as I walked around, I didn't see every single person's paper, but everybody that I did see, they had this factored out as the GCF, right? Great job. The leftovers are x squared minus 9x minus 22. So, what do I do from here? I look at the inside and I ask myself, is the inside a binomial or a trinomial? 3 terms. It's a trinomial. What mechanism do I use? What feature do I use to factor a trinomial?
ABC.
The boxes with the ABC thing. That's right. So A is 1, B is negative 9, C is negative 22. AC is negative 22. B is negative 9. You guys remember doing this? So now you could use your calculator to do this. There's a number of ways you can do this. but I'm hoping that eventually you would come up with negative 11 and 2 as your two special numbers for the box. And here's the box. X squared goes here. Negative 22 goes there. And then maybe negative 11x and 2x. Remember those two other diagonals that didn't really matter the order you use there? Okay, so here's how this works. On this arrow here, I want to factor out my GCF. What's in common?
Negative 11.
11. Why negative 11?
Because it's the last one.
Because that's the
Finishing
last
box
one.
is negative. That's right. So negative 11 goes here. How about the factoring along this red arrow? What's in common? They both have an x. That's correct. So my first factor is going to be x minus 11. Factoring along this green arrow. 2 is in common, but should it be negative 2? What should be?
Positive. It'll be positive.
The finishing box is?
Positive.
Finishing box is positive, so you go with positive 2. I had to ask. That's why. Okay, and then how about the one that's unmarked? What's in common? X is correct.
X,
So guys, here's your final factoring.
2 plus X,
2x
11.
times x plus 2 times x minus 11 equals 0. Once I have fully factored, hey guys, quiet down. Once I have fully factored it, what property do I use?
The zero factor.
ZFP, right? Zero factor property. 2x equals 0. X plus 2 equals 0. X minus 11 equals 0. So your final answers be 0, negative 2, and 11.
Then I solve it.
3 answers. Yes, ma'am.
So wherever there's an x, you just use the zero factoring property. So like wherever there's like
Yeah.
like 2x.
Any factor that has an x in it, you set it equal to 0 and solve it.
Okay.
Yep. Exactly right. Hey, why don't we practice this again tomorrow?
Yes. Let's.
Have a good rest of your day. Retake the what?
Like, and then this comes.
Right now.
You said, twice.
Yeah. Let me get my other class rolling, because it'll just take a minute for them to. Let me at least get it set up for them.